Hello everyone. So today we will be creating a very simple process model in Arena for a manufacturing plant for a particular workstation where parts are coming with an exponentially distributed interval time of 5 minutes to get processed in a drilling station. The workstation is equipped with one drilling machine and the drilling time is triangularly distributed with a minimum value of 1, maximum value of 6, and most likely value of 3 minutes. So our first target is to develop an Arena model for this process, and then we would like to run it for 20 minutes and report back some of the statistics value. So let's go ahead and open Arena for our modeling. All right, let me minimize this window, and over here I'll just take this off. So this is Arena. If you have already installed Arena in your computer, you can just go ahead and type in your search bar Arena, and then you'll have this icon over here. So just double click it and you'll be directed to this part of Arena where we will be doing our modeling. For this process, we'll be using basic process panel. So Arena has created different templates which we could be using to develop models. So right now in the beginning stage and for this very simple process, we'll be using basic process panel. So if you already have this panel, good. If you don't have, you can just click in attach, template attach, and then you'll be directed to this template folder from where you can select basic process, advanced transfer, and other panels. So if you are not referenced here, there is a way to get in over here. So let's say maybe after clicking this, you are in your desktop for some reason. So how to get back to this template folder? Go to C drive, go to program files, and then go to Rockwell software and then click Arena, and over here you can see template, right? So click template and select the template you want to add to your workspace. All right, so we already have basic process. I'll just say cancel for now because I have it already. And let's say advanced and advanced transfer. I don't want this template here. So how to remove it? Just click over here, detach template. So if you select that template and just hit detach template, that template will go off from your workstation. All right. So we'll be using create module, process module, and dispose module for this simple process. So in the beginning, I would request all of you to save your file first, as if your program crashes, you'll at least have something saved from where you can work on later. So let's go ahead, let's go to file, let's click save as, and then let's just name it drilling process model 1 or whatever name you want to give your model. And then look over here, the file extension, it's .doe. So whenever we create a new file, we usually create a DOE file. However, when we run it, other files like M files, output files, and some other upquest files, pan files get created automatically that you can use for doing output analysis later on. So right now we are just creating a DOE file, which we need. Hit save and see over here, you will get to see the name of this file that you just created. All right. So over here I have grid marts. So if you don't have them in here, how to bring it? Go to view, go to grid. So it was already checked in, so I had grid. So if I want to bring it back, I'll just go to view and then I'll hit grid and it's back. All right. First of all, in our model, we need to create our entities, which will get processed through the system. So we will be using create module for that. So it's just drag and drop. Go over here, select the module you want to bring to this workspace, and then just drag it and drop it here. So I have a create module. So let's try to edit this module first. So go ahead, double click on it. You'll be directed to this input interface. So the first blank asks for the name of this module that you want to give. So let's just name it create part arrival. Don't need to, you can put module, but no need to do that, because just put a reasonable name for the module. Like if this is the box, this name will be shown here. So if you have similar shaped box, similar kind of modules that you'll be using throughout the model, try to keep the name as reasonable or as close as possible to the work that this module is doing. So it's creating a part, so we just titled it create part arrival. Next, we have to create entity. So in our system, entities are parts. So instead of type, you could just think that you are assigning a name for your entity, which will be created by this create module. Next, time between arrivals. Okay. So in the logic, we saw that time between arrival is exponentially distributed with 5 minutes. That means each parts are coming on average 5 minutes one after another, and it's exponentially distributed. So first of all, we need to select the type of expression. So by default, exponential is already selected. So we will just click on it. Your part may arrive based on some kind of schedule, or they might arrive constantly one after another, or they might follow some kind of mathematical expression. So for now, let's just select expo, and the value is 5. Unit is in minutes. All right. Next, over here we see entities per arrival. So we are not including batch arrival here. So at every time entities are getting created, only one entity will enter the system. That's what we are specifying here. Maximum arrival, we are not controlling the total number of entities that will enter the system. That's why it's infinite. First creation, we want our first entity to be created at 0 minute, or at 0 second, at 0 minute, let's say. That's why it's 0. So that's all basically. So we'll hit OK. So we'll have our first create module. Next, we will bring in process module, because entities are coming in and then they're getting drilled. What is the name of our entity? Parts. Good. All right, so I have create and then I have process module. I need to interconnect them, right? So that entities flows from one point to another. So over here from the standard toolbar, go ahead and select connect and then connect this to module. There's another way of connecting two modules. Let's just take this off. If I pre-select my adjacent module and then drag and drop a new one, it automatically gets connected. All right. So in the process module, let's go ahead and edit our process module. Double click on it and let's just name this module as drilling process. Type standard, because we haven't created any submodule here, and then we come to logic action. So logic action would be seize, delay, release, because entities are getting created, coming over here, seizing a resource, getting processed, and then releasing it to get to another part or getting disposed. That's why it's seize, delay, release. Sometimes it happens that entities arrive, they seize a resource, they get processed, but maybe there are some holding that is going on in the system. That's why it does not release this resource. It's still waiting there. So it might be something like that. So in that case, we might use other logics, but for now, it's seize, delay, release. Seizing, getting processed, and then releasing it. Priority is 2. So if same resource is being utilized by different processes, through this assignment, we can tell Arena that which process will get priority over using a particular resource that will be referenced here. So let's go ahead. That's why right now we just have one process. So it's medium or high, it's fine. Or low even, it's fine because we have just one process. So over here, always remember that for processing something, you need some kind of resource. So you have to add that resource. So come over here and then click add. That will help you to add your resource for the processing. Your resource could be single resource or it could be a set of resource. So right now, let's say we just have one drilling machine. So name of the resource, just to make it more practical, we'll name our resource as drill machine. And over here it says you need to seize / release. It's 1. Why it's 1? Because each time an entity is seizing the resource, you just need one drilling machine to get processed. Let's say if we had 2 drilling machines, if I put 2 here, that means that entities will come and seize both of these machines to get processed, which is illogical for this simple process. But if you think of agent-based processes, then 2 agents might be serving one entity at a time. It might be something like that. Maybe in a shop, maybe in airport, maybe in hospital. If 2 nurses are required to serve a patient for their surgeries, then you'll put 2 over here, something like that. But for now, it's just one-to-one mapped assignment. So we'll put 1 here and then hit OK. So we have our logic, we have our resource, and then we have to tell Arena about our delay type or about our processing time. So here we said that it's triangularly distributed. So triangular is pre-selected. However, it might be uniformly distributed, normally distributed, or it might follow Weibull distribution. You can add them up later on. But for now, let's just hit on triangular. Unit is in minutes. And then allocation is value added, but it could be non-value added process, transfer process, wait process, and so on. So it will be value added. Minimum is 1 minute, most likely is 3, and at max it's 6 minutes. And this box is checked in. So if you want a report about your process, then you have to check this box in and then go ahead and declare it in run. We'll do that eventually, but by default it's ticked. If you don't want, you can uncheck it, but it's always good to have more stat. All right, so over here, then click OK. So part is generating, arriving over here, getting processed or waiting in queue and then getting processed. After that, you need to dispose the parts from the system, else Arena will generate error, like it doesn't know where the part will go. And I want to just zoom in this region. How can I do that? I'll go to view region and then I'll select the whole frame. Okay, now it's zoomed in. Let's just name this Disposed module as parts leaves the system. And if this one is checked in, it will basically give how many number of part has departed our system so far. So you see it's 0 over here. At the end of a simulation run, you will see the number of parts that has been created, got processed, and then left the system. Or if it didn't get processed and then you have a disposed module after that, this part will reflect the number of parts that got out of that disposed module. So by default, it's ticked in. If it's not, then just tick that in. It's as simple as that. Then click OK. So we have create, we have process, and we have disposed module. The last thing we need to do here is go to run and then go to setup. Over here, you'll be directed to replication parameter interface. So the first thing you need to declare is number of replication for this simulation. So right now we are just doing one replication. If there are more replication, more than one, then this toolbar basically defines whether you want to initialize all the statistics value between replication or not. Do you want to initialize your system between replication or not? And then you can define the start date and time. It's automatically selected. It automatically pulls your computer clock. So if you want to set it for a different time, you can go ahead and just type that in. Warm-up period will come over here later, and then replication length. We wanted to run our simulation for 20 minutes. So I'll just type 20 here and then select minutes over here. And here it says how many hours per day, 24 hours. We're just running it for 20 minutes. We don't need to bother about it. This basically just says the working hour for the process. So let's say a hospital, outpatient clinic, it just works from 9 to 5. So we'll just type in 8 hours or 9 hours or whatever hours it works here. It works daily. And then base time unit, it's in minutes, let's say. So all the output statistics that we will get from Arena after running this model will be in minutes. That's what we are specifying here. So we are inputting our inputs as minutes, so we want our outputs as minute as well. All right, so in replication parameter, you can put all this. If you go to project parameter, you can just type in the project title. Let's just say this is simple drilling process, and analyst name, let's say Arena model. Project description, let's say parts are arriving and getting drilled. That's what description of this model is. Whatever you want to put over here. Statistics collection. So if you want to know about costing based on how many and how long entities are waiting, how many entities are being processed by your resources, you need to check this in. For now, we are not requiring that kind of analysis. Entities, if you check in, then it will generate report about entities. We really want to know the average total time an entity is spending in the system, or the waiting time it's spending in the system. And then resources, about its utilization. We really want to know about queues. And about process, most of the things that are reported in resource and queues are similar to whatever is being reported through process. So we won't check this in right now. Let's just get output about entity, resource, and queues. And let's click OK. Let's hit save, and then let's just run the model. So before we get into the result, I want to bring your attention in. So 7 part was created within this 20 minutes simulation time, and then 5 part left the system. That means 5 part got drilled and left the system. Over here we can see 2. That means one of the part is still getting processed in the drilling machine, and one of the part is waiting to get processed. So 2 of them are like work in process by the end of 20 minutes, and 5 of the part left the system. So if you add these 2, this should always add up to 7. Add up to the number of entities that entered. So work in process plus part departed, entities departed will add up to whatever number of entities that has been created in the system. All right, let's go ahead and say what it says. The simulation has run to completion. Would you like to see the result? Enter yes. And then you will be directed to automatically categorized report that Arena produces. So over here, see, we in the project parameter, we titled this project as simple drilling process. That's why we have this name here. So click on this small plus sign, and we said we want stat about entity, queues, and resources. So that's what Arena generated. So the first page, it shows the date and time that we initialized, and then at what time the report was produced, how many replication was there, and what's the name of the process, what's the base time unit, the key, and then it provided key performance indicator that 5 part on average has left the system. So over here, this column is titled as average. However, we just did one run. That means whatever value number out had in this run is called as average, but it's not basically average. It's whatever that we get from this one run. If let's say for first run, the total number of part that went out was 5, and for the second run was 6, then total would have been 11, and then we would have divided it over 2. Then the average number of part that went out of system would have been 5.5. That's what it is. All right, let's go ahead and check in entities. For entities, it creates bunch of times. So what kind of time is being created here? VM is value added time. That means service time. So on average, 3.04056 minutes each entity has spent in the service. Minimum was 1.76 and maximum was 4.51. Halfway is insufficient because we just ran it for 20 minutes. We need to run it for 8 hours or more on average to get a half width. There was no non-value added process, and the wait time for each entity was on average 3.0340 minutes. So then we didn't have any transfers, and then there was no other time where any entity spent have been waiting or spent some time other times. So the total time is simply what you would get by adding the value added time and wait time for this simple model. So if you add these two numbers over here, this one and this one, you'll get this value. So on average, entities spend around 6.4397 minutes in the system, and one entity spent around 2.8956 minutes, which was minimum value, and one entity really waited or get processed for long. It took around 12.6185 minutes for that entity to get processed. And then if you hit other, you come here and see the number of parts that entered the system. That was 7, and number of parts that departed the system, that was 5. And on average, the work in process of parts were recorded to be 1.7006. That means at each instance, if you take a look at the system on average, you will find this part. See over here, you will think like, how come this can be in fraction? Because what it does is that every discrete time when the status of the system changed, whenever an event took place, it went ahead and recorded how many parts were there in the system at that time, and then it divided so for all those values, it added up for the whole run, and then it divided it over time, which is 20 minutes here. So that's why it's in fraction. However, if you look here, the minimum value is 0. What does this mean? At any particular instance, there are no part in the process or no part in the system. That's why it's 0. And at max, there were 4 parts in the system. Maybe one of them were getting serviced and 3 of them were waiting in the queue. So that's what you find from total working process. Let's go to queue statistics. So let's go to queue time. So we just have one process here, and the name of the process is drilling process, and it does have a queue that automatically got created. On average, parts were waiting for 2.52 or around 2.53 minutes. So each part on average was waiting this much. Max waiting was reported for by an entity for 8.1598 minutes. So it really waited long. And then on average, there were around 0.7889 parts in the queue, and max that was being observed was 3. So at particular instance, 3 parts were waiting in the queue, and minimum is 0. That means none of the parts were in the queue. Let's go to resource. So in resource, we can see it has instantaneous utilization. That means the efficiency or the system efficiency over here. Average is 0.917 or 91.7% of the time the machine was busy. Minimum is 0. That means at particular instance, maybe machine was not working. At max is 1 because we just have one drilling machine, and that's why the maximum value it can take is 1. Number busy, it's the same because that's the percentage of time for which drill machine was being used. Number scheduled, we have a fixed capacity, so it's 1 throughout. Scheduled assignment is also same, but if the resource capacity varies based on schedule rather being fixed, this number over here and instantaneous utilization would vary. And total number seized is 6. That means 6 times our drilling machine has been seized. So that's the statistics we find through Arena. Let's go back to Word and see what are these stat values that we need to report. The first one is total number of parts entered the system. Where we can find that? Let's go to Arena. Let's go to Entity and let's click Other. So total number of parts entered the system is 7. So we'll just come back and just put 7 here. Total number of drilled part exited the system. That basically just means how many part has been processed within this 20 minutes. 5, right? All right, so 5. Maximum number of parts in the system in a particular time. Work in progress over the 20 minutes run. So work in process, average is 1.7. However, it asks for maximum. So maximum is 4. So put over here 4. Average number of parts in the drilling queue. So it's a queue stat. So we'll go back to Other and then save this value. Sorry. Over here, average number of parts in the drilling queue. So here, average number of parts in the drilling queue is number waiting, which is 0.7889. So we'll go ahead and put 0.7889 minutes. And then average waiting time of parts in the system. All right, that means it's talking about entity. Don't put just this one. So let's go to waiting time. So each part has almost waited 3.0340 minutes in the system. So 3.0340 minutes. Maximum total time of parts recorded in the system. So over here we see total time, maximum is 12.6185 minutes, which is 12.61, right? Yeah, 6185 minutes. Instantaneous utilization of the drilling machine. So we go over here, we go to resource, we go to usage, and instantaneous utilization is 0.9171 or 91.71%. So that concludes this tutorial. Next, we are going to do some improvement to this process just to include decide module. So stay tuned for the next video. Thank you.